Brief review of the unit circle and how it can help us remember exact values of trig functions. So remember, the unit circle is a circle centered at 0, 0 with a radius of 1, and its equation is x squared plus y squared equal 1. So we easily know the points that lie on each axis there. And then we can get any other point on the circle if we choose an x, put it in this equation, solve it for y kind of thing. For example, if we put x equal 1/2 and solved it, we'd get square root 3 over 2. So that's another point on our unit circle. Now, if we made a triangle here and we labeled the sides of the triangle, we have over 1/2 and up square root of 3 over 2, and we used our right triangle trig. That's the connection between right triangle trig and the unit circle. The unit circle is just a fast way to get at all of these by just doing a quick sketch, kind of out of your head type thing. But remember, if we wanted sine, it's opposite over hypotenuse, and so we could do that with this triangle. And if we wanted cosine, adjacent over hypotenuse, we could do that as well. But we notice the sine value is just the y value on the unit circle, since the hypotenuse is 1, so it's always over 1. And the cosine of theta is always going to be that x value, and so we can utilize this and just be able to plot a point on the circle and know if we need cosine theta, it's x. If we need sine theta, it's y. If we needed tangent, that's opposite over adjacent, so that would be sine over cosine. It would be y over x. So now basically, if we want a trig function and they give us this point on the terminal side, we can easily answer that by looking at these points on the unit circle in any given place. If we had this particular one, we wanted to know the sine of theta there, we would just simply take the y value there. And if we wanted to know the cosine of this angle, we would simply take the x value there. And makes it very easy to get at these trig functions. Tangents, we would do y over x. Okay, so we can divide this into various pieces. If we took the circle and we divided it into 8 pieces, we would have these angles that are 45 degrees apart. And of course, in calculus, we want to work with radians. And so we would have our radians around there, and that's the thing that we will be interested in. It's easy when you divide it into pi-4 pieces, because we've got all of our angles that fall on axes as 1, 0, zeros, 1s with negatives or not. But then all of those other points on this circle, as you can see, land as square root 2 over 2's. So they're all square root 2 over 2's, but then we just put the appropriate sign based on the quadrant. In quadrant 3, both x and y are negative, and so forth. So that makes it pretty easy to get at multiples of pi over 4. The answer is going to be square root 2 over 2 or negative square root 2 of 2. And we figure out what quadrant we're in and what sine or cosine sign is there, we've got it answered. So sine of 7 pi-4, I just need to come around here, and it's just the y value, as we show here, negative square root 2 over 2. Now we could divide this circle then into 12 pieces, and so they would all be 30 degrees, and of course we want these in terms of radians again, so that each of these segments would be pi over 6. And the pattern here is they are all square root 3 over 2 and 1/2 in some order, and then appropriate signs for quadrants. And so as I look at this first one, and if I looked at the triangle here, this is larger x, smaller y, so larger x, smaller y, I know square root 3 over 2 comes first. If I looked at this one, which is pi over 3, I see I have a smaller x and a larger y, so I would know that the 1/2 would go first. And just knowing those things and knowing that it's 1/2 and square root 3 over 2, I could very quickly devise any of those that I needed. So here is our unit circle with all of the angles in there. It's nice for reference, but you should be able to pull this completely out of your head so that you could just sketch a quick angle to get this. For example, If I wanted to know the sine of pi over 6, I'm just going to do it off to the side here to show you. If I didn't have this big unit circle here, I would just do a quick sketch. I would make a pi over 6 angle, and I know it's pi over 6 or pi over 3 in this quadrant. So pi over 6 is the one with the larger x, smaller y, so I know it's larger x, smaller y. And now I could easily say cosine of pi over 6 is square root 3 over 2. Sine of pi over 6 is 1/2. So knowing these unit circles, being able to do a quick sketch enables us to get at any of these. If I wanted to know the cosine of 7 pi 6, I go, oh, 7 pi 6 is over here. Okay, that's larger x, smaller y, so I know it's square root 3 over 2 and 1/2 again, but in quadrant 4 I know x's are positive, y's are negative. So the cosine is square root 3 over 2 and the sine is negative 1/2.